Hello YouTube viewers, welcome to my channel S2T. In today's show, Science Thursday, we're going to talk about flow batteries. So let's dive right into it. But first we have to understand what the heck we are talking about. We are talking about something that is more closer to a fuel cell than to a battery. But you have to understand that this is a rechargeable system. It's not like aluminum air batteries where there are use and throw. This is a rechargeable system. And the electrolyte, basically, if you are familiar with any types of battery, you know they have two components. Basically, you have cathode and you have anode. In this sort of chemistry or architecture, basically flow cell battery, both of them are in liquid state. That is a most critical component. They are in liquid state and they generally require liquid pumps to circulate them. It's not like heat pipe where the heat energy itself moves the fluid inside. It's not like electricity or the chemical energy is moving them. You have to have a pump that is circulating them, and all the reaction, all the magic hoo-ha that happens in ion exchange membranes. So that's the reality, or basically something like this. That's the quote-unquote cell. Now, how the heck it works? Now, it is a very simple but very complicated situation. So I'm gonna ask you to remember your old school lessons of redox, aka reduction and oxidation, aka transfer of electrons from point A to point B. Basically, if an atom gives a electron or if an atom receives it, that's it. That's all that's happening. And if you are familiar with electricity, you know transport of electron from one point to another or oscillating them is the electricity itself. So whichever fluid that we want to do, because you have to understand this transfer of electron, its oxidation happens in everything. If you burn wood, that's the same thing. You're getting energy out of it. Now, problem is that you cannot recharge it. So we want something that allows us reversible electron transfer. Basically, it should have state in such a way where you're like, okay, I can either extract electrons from you or put it in you, aka charging you. So that's the reality of it. Now, because you are talking about two fluids, both of them have to interact with each other without mixing with each other, because mixing it would be equivalent of a dead shot. So we employ what we call membrane. Now membrane is the surface area, basically the basically block and the surface area. This allows ion from one point to another to jump. Basically it does not allow the basically the whole molecules to go from one point to another, but does allow ions to transfer through. Now the benefit of that, this is the place where the reactions happen. So the bigger the surface area, bigger the membrane surface area, the more power you're gonna get out of it. But you have to understand that how long your battery is gonna last, or aka how many hours it can run, that directly depends on the fluid system you have. So if you have 1 liter tank versus 10 liter tank, 10 liter tank will run longer. So that's the reality of it. Now when you understand this, basically all it is just transfer of electron from point A to another and back and forth when you want to charge it. There are many chemistries that allow this kind of situation, and Wikipedia have giant links of that. However, the easiest way to explain that is basically vanadium system. Now vanadium is a metal, and the benefit of that, it has 4 states in itself. Basically how you have oxygen, which can be just oxygen, or it can be O2, or it can be even O3. So same way vanadium also have states. So it has 4 states basically, where it could be V2 plus, V3 plus, V4 plus, V5 plus. So you're like, what the hell? That simply means 2 of them are negative, 2 of them are positive. So what we take is basically take the tank of vanadium and separate it out based on the charge. Once you do that, what you will have is V5, aka that means it's the positive side is charged, and you're gonna have V2. So what you're gonna do is basically take electron from 5 and dump it into 2. 2 will become 3, 5 will become 4. You discharge the battery. You are taking energy out of it through the electrical load. The electron transfer path is there. Then to charge it, basically when you are pumping electricity into it, you will simply like 3 will basically dump the electron again, and it will end up with V2, aka in charge state, and 4 basically the 4 that was happened in the discharging phase will end up charging, because it will receive 1 electron and it will become V5. That's all happening. Basically 2 is going to 3 when it's discharging, and in charge state it is going from 3 to 2. 4 is doing the same. Basically 5 to 4 is discharging, 4 to 5 is charging. That's all that is happening, basically electron transfer. Now this is the simplest situation, because even if there is a hole in the membrane or damage, or even if the fluids gets mixed with together, all that will translate to is basically your system is discharged, nothing else. So that is why many people prefer it. And if you type flow cells battery, most likely you will come up across with something like this, because this is the simplest thing, and it is so simple that you can build it in your home. It will not be very energy dense, but it is something doable. So that's the working of it. You have something that allows you to basically put it in charge state or in discharge state. Or if you are still having hard time understanding this, think of this way. You can do this with water also. You take the water, you electrolyze it, that is you're charging it. Now you make them into gas. Now you take the hydrogen gas and oxygen gas, then you burn it in a fuel cell, you get the electricity out, that is the discharge, you get the water vapor output. That's the same thing. Now do that in closed cycle, you will get the same battery. Only difference would be when you are doing with hydrogen or oxygen, you are dealing with phase changes. Basically liquid is going to gaseous state. Here no such thing happens, the state does not change. That is why the electrical efficiency of these puppies are much more higher compared to, let's say, the best case scenario you're gonna get of a fuel cell is around 60%. These puppies are around 80 to 90%. So there, it's still not as good as a battery which is like 99 plus, but it's very close. Like this is very close. So that's the reality of it. It's just almost everything does the same thing. It's just you are simplifying it, and you're like, do not change state. That wastes a lot of energy and also heats up your system, which you have to cool down. So that's the reality of it. Depending on your budget, depending on your energy requirement, depending on things that you are seeking for, there are different chemical options. Vanadium is the cheapest option. People don't like it simply because vanadium only China has the reserve of it. Now let's say you built it. What about the power and energy aspect of it? Now power and energy sounds same, but they are different. So what does that mean? That simply means power is energy multiplied by time. Basically you take 1 kilowatt. What does that mean? That does not mean something. That's like, okay, 1 kilowatt of energy, but when I say 1 kilowatt in, let's say, 2 hours, that gives you power of 500 watts. But when I say like 1000 watts per hour, that's 1 kilowatt. That's the power rating. Basically how much energy you are consuming per unit of time defines your power. Now think of it this way. You have a generator in your home, and let's say power goes out, it goes out for a very long time. It rarely goes out, but whenever it goes out, it's like, yeah, it's gone for 1 or 2 days. You're gonna have a giant fuel tank but a small generator because you are running a home, it's not too demanding. But think of this way. Let's say you are talking about a server home, giant Google server. Now because they are Google, they have multiple electrical system that is providing them power, so they do not suffer power loss. However, some things could happen, something bad could happen. They have multiple feeders, but things could happen, and feeder does require you to change from one electricity to another. So something bad happened, power went out. However, the energy requirement for that short time would be huge. They will be needing megawatts of power. So what you're gonna do here, you need a lot of power, but you do not need too much energy because you only need it for that 5 minutes, 10 minutes, or 20 minutes, something like that. So that's the difference. Reality is same as generator. You can have a giant generator or a small generator. You can have a giant fuel tank or a small fuel tank. That's all. In this battery, that is the unique ability of that both of them are separate component. So if you need let's say a battery that is designed for some heavy application, you're gonna have very large membranes, which is the main energy component. You're gonna have huge membranes, like hundreds of square meter of membranes. Again, not in one cell, you're gonna have multiple of them for voltage reasons, because most of the cells are limited to 1 volt or 2 volts best case scenario. Comparison lithium ion is 3 volts plus. So in those sort of scenario, you're gonna have hundreds of, like, total surface area will be huge. But if let's say you want running a home customer, but power outages is very long, you're gonna have a tank that's, instead of let's say 10 liter, would be 100 liter long. That's the reality of it. Both of them can be separated and they can be fine-tuned for your exact need. So that's the amazing aspect of it. Let's say you are like, hey, I do not consume too much power, but my solar panel produces enough power, but I have to store it for whole night. You need to store it for whole night. So you're gonna have large tank, but you're like, all you are doing is just consuming the power instantly. You just want to use battery as a buffer in case of a power fault or something like that. You are using it as a UPS. You're gonna have large cells, but the tank size will be small. So this independent controllability is unique to this, and it is amazing because this allows something interesting. Now if this is so good, it's like, you can charge it, you can discharge it, you have fluids and all that jazz. Why not everybody is using it? Because if you research this, you will find out this technology is kind of ancient at this point in time. So you have to understand this. Most of the batteries, when you are talking about, they are not moving parts. They do not have moving parts. They are solid state. This puppy has moving part. It is not solid state. So forget about putting this in a car. Even it's difficult to put this in a boat or something like that, because it has fluids that you have to manage. You have to make sure they are perfectly sealed, not getting contaminated by anything else, and not and all mixing with each other. Because even if you have a circuit design that allows you to mix them without destroying anything, you will still lose your electrical charge. So that's the reality of it. It is not solid state, so it has moving parts. Now the primary of the moving parts are the pumps, because two electrolytes are there, and basically anode and cathode. You have to pump them, and you have to make sure the two separate pumps are used, so you cannot have bearings leaking and mixing with each other, and that becomes a point of failure. Now On top of that, even with that kind of limitations, we have things that have moving parts, like your car engine, which has 600 plus moving parts. So that's not an issue. We can make moving parts that last very long time, but the energy density is very bad. Now, for example, this is a different chemistry than vanadium chemistry. This uses zinc bromium. Now this puppy is a 10 kilowatt unit. Now, okay, that's good and all, but to give you a context of the size difference, if you use a Tesla's power one, it will be like one third of this. You just take this, squash this, you will get Nikola Tesla, I'm saying, Tesla's power wall. So that's the reality of it. It's very space consuming. Per liter efficiency is bad. So those are the consequences of that. Now, what are the pros of this situation? Now, pros is the one of the only pros there is like that matters, is simply because it allows you to be huge. When I say huge, I truly mean the aspect of that, because China is building something 800 watt hour kind of capacity. Let that sink in. 800 watt hour. That's the reality of it. It can be scaled to ludicrous degree. Basically, you want to run something like Mumbai, which consumes 30,000 megawatt. Yeah, you can do that. It's like it has no problem. It's inherently simpler. You can just make them as big as you want, as many cells as you want, or as large a tank as you want. That's up to you. Heck, Germany is even trying to use underground as a tank, because again, it's cheaper that way. So that's the reality of it. And in terms of what elements are used, because you have to understand, when you're talking about lithium in your mobile phone, it's not that much. It's in not that many grams. However, the expensive part in your mobile phone is the cobalt that is used in your batteries. Those are expensive. So when you're talking about in kilograms of battery in your day-to-day consumption, it's not too much. When you're talking about electric car, now you're talking, because now you're talking almost 200 kilograms. But when you're talking megawatts of power, you're talking almost the production output of a country to get even 500 megawatt capacity. That's the main reality of it, because the inherent components that are used in this are so simple, and basically the elemental value is so cheap that it can be done. Basically, zinc bromide batteries, both of them are abundant. Both of them does not require, like, okay, China only has that, even India has that. So it does not require something expensive. Inherently, everything else is simple. Heck, you need to build tanks. We can build the tanks out of plastic itself, and all you have to do is enclose it in something that protects it against ultraviolet, aka steel tanks. So you can have something very simple, very long lasting, very reliable. Now, the design and implementation of this way is quite simple, because you can literally have giant tankers, two tanks, positive and negative, and you're gonna have fuel cell. And if the power consumption is low, you're gonna add another fuel stack, so you can do that. It's literally same way as a diesel power plant. Nothing too complicated, very simple, inherent systems. Another aspect of this, which is very unique, because both of them can be separated, aka anode and cathode can be separated. You can eliminate self-discharging, aka you can charge the battery in summer and use it in winter. That's possible with this puppy. This has no self-discharge. Basically, you can even some people are used to the situation. Again, it's not recommended, because why you are doing this is, but for lab purposes, they have done this. Is basically they charge the fluid, they remove the fluid in charge state. Basically, anode and cathode, they kept it separate, and then keep doing it with fresh one. And then to discharge it, you can keep continuously adding it. Let's say your battery was designed with 10 liter capacity, you can have drain valves. It's like just drain the whole fluid and then pump in new one. Basically, you can putting liquid energy into the situation. It can be done if you want it. So that's the reality of it, and that allows a long-term storage. So you can have in summer, solar farms are producing YOLO amounts of power, and in rainy seasons, wind power is producing YOLO amounts of power. But this you need something that can hold charge for almost a year. This puppy can handle that. This can handle it, quote unquote, indefinitely. That's the amazing reality of it. Now, you are still talking about membranes, you are still talking about things moving, so it has a cycle life. It's not infinite, it will break down. Now, barring simple things like pipes or pumps and all that jazz, the membrane itself has a life limitation. To give you a context, that they are generally measured in what we call charge and discharge cycle. So a normal lithium ion, basic normal lithium ion that is used in your laptop, power banks and mobile phones, they are rated for 1000 cycles. This puppy, 20,000 cycle warranty. So it's huge. It's huge. It's gonna last you very, very, very long time. So that's the reality of it. And even let's say your battery breaks down, it is because of the modular nature of it. Without actual nature, you're not going to have a scenario where your fluid breaks down. It's very unlikely. It will be contaminated again over time, but some fluids are inherently simple. Other fluids flat out cannot be contaminated unless you spend time to contaminate it, and all the things that is going to degrade is membrane. You can just open it, replace it with a new one. So you can, instead of recycling, you can just repair your batteries. So there are amazing pros for this, but in a large scale. Like the smallest scale feasible is basically 10 kilowatt hour unit, which is for home units for Tesla Powerwall. And right now they are 3 times more expensive than that. However, they will last also longer. So people who have bought this, they are happy with this. And because it does allow you to almost get put 100 kilowatt in, get 90 kilowatt like out. You can get like almost, and you can do this every time. Deep discharge does not cause any issue to them. So there are a lot of pros of this. So this was my presentation on liquid flow cells batteries. I hope you liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I'd urge you to press dislike, press it twice to show me your disappointment, and please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.